All right, so let's talk about the circuit lab equipment that you use to measure things. And there's really two main pieces of equipment because there's really two things we're going to measure. We're going to measure voltage, we're going to measure current. So ammeters measure amps. They measure the current going through the ammeter. Okay, so the current has to pass through directly through. So that's why if you want to measure something like some circuit element, you want to put it in series with the circuit. That is, has the same current as the element. So for example, if I have a resistor here, I want to put the ammeter in series with this, right? Because then any current by, Kirchhoff's current law, any current that goes through there is going to also go through there at the same time because there's nowhere else to go. What you don't want to do is you don't want to put it in what we say parallel or have it not have the same current going through it, right? So if you do this as an example, like any current that goes through the resistor, it was not going to go through the ammeter necessarily. So that would be a poor way. This would be an incorrect way to set it up if you're trying to measure that. So it has to be placed, we call that in series. In series just means same current. The ideal ammeter has zero resistance because you see, if you had a resistor here, it would affect how the circuit responds, how much current flows. So the ideal one has zero resistance. Obviously, realistically, can't be exactly zero, but ideal is zero resistance, and when you analyze it, we generally assume ideal. When you're working in a lab, like with an actual real ammeter in front of you, you may have to consider it. But usually these resistances are very, very small and much smaller compared to the things that are in the circuit, or at least that would be the intention of using a good ammeter. Okay, the voltmeter sounds like what it is. It measures the potential difference between 2 points. So it's one of those things, it'll measure the potential difference between here and here. It needs to be placed parallel to the circuit element so that it has the same potential difference. So for example, if I have a thing like this, right, and I want to talk, I'm going to call this potential difference here V of the Vm is what we're measured, and then this is the voltage across the resistor. We want those to be, this is in parallel configuration because it has the same potential. And you can see this by KCL, if I do a loop rule right here, right, I would say I go up Vm and then I go down Vr and that equals 0, like just that loop right there. And so the Vm is equal to Vr. So whatever the voltage across the voltmeter is this exact same. So this is called a parallel configuration. Both ends are connected to each other. Ideal voltmeter has infinite resistance because we want like if we place it like this, we want any current that goes through here would have gone through that resistor also. We don't want any current to go through here. So it has infinite resistance to say that there's no current going through it, right? So that way any current that would have gone through, because we don't want to interfere with what the circuit was doing. Right, so an ideal voltmeter has infinite resistance. Generally, it's very, 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 very large, much larger than this one. So it's effectively, approximately infinite, but realistically, it's not infinite. So let's just go through a few examples. Draw the correct location for a voltmeter and ammeter to determine the power for the 2 ohm resistor. So this guy right here, I want to measure its power. So that means I need to know its current and its voltage going through it. Okay, so the ammeter, I'm going to put right here to be in series. And then the voltmeter, I'm going to put across it like this, so that it shares this connection here, so that we're measuring the same potential difference, and whatever current goes through that resistor goes through the ammeter. And that's exactly what we want, because we want the voltage across the resistor and the current through that resistor to determine the power for that resistor. And that's it. That's pretty much straightforward. That's how it works.